we're going to be working on our Abeka geometry book. We're in 1.4 Equalities and Inequalities. We're going to learn a lot of principles today. We've already learned Principle 1, Principle 2, and Principle 3. Now we're going to learn 4, 5, 6, 7, 8, 9, 10, and 11. We're going to do some examples on each one of them just to get a better feel for them. Most of them are pretty intuitive, that it makes sense. But once we start seeing it with lines and stuff like that, it may look a little bit different, but the concepts are the same as if it was numbers. It's probably the biggest thing in geometry that's different is we're not dealing with numbers like we're used to. Not directly anyway. All right, so we're going to start off with two magnitudes. We've talked about magnitudes previously. So two magnitudes, A and B, may have one of three relationships with each other. A may be equal to B. So A, whenever A is, might be equal to B. A could be greater than B, or A could be less than B. That's the three relationships that magnitudes have to have with each other. They can either be equal to each other, one can be greater than the other, or it can be less than the other. All right, so that's pretty straightforward. Nothing mind-blowing yet. All right, these three relationships are represented in order as follows. So we have A equals B, that's an equation because it has an equal sign. A greater than B, A less than B, these two are inequalities. So these two are how we represent inequalities as to where this one is an equation. All right, so let's look at the think it through section on this part. You're gonna need your compass. I only have a little compass. I don't have the big one for the dry erase yet, so I'm gonna have to make do with what I have. It'll be a little bit easier for you on a smaller scale on your paper. All right, so think it through number 1. It says to represent by a line each of the following expressions in which A, B, and C represent line segments such that A is greater than B, B is greater than C. I've got 3 line segments. A is greater than B because it's clearly longer. B is greater than C because it's also clearly longer. So I've got my 3 line segments. A is greater than B, B is greater than C. So it wants me to represent that and to find first, we'll call it number 1, part I. All right, looks kind of funny, but it is what it is. A plus B plus C. It wants us to represent A plus B plus C. All right, we talked about this a little bit yesterday. What we need to do is to make a straight edge that will exceed these 3. So I'm going to use a straight edge to make a line. All right, I believe that to be long enough to exceed the 3 of these joined together. Now I'm gonna do it. So I'm gonna take my compass. So on your paper, you're gonna take your compass and you're gonna stretch it out to match the line. All right, I've got my left end on the very left side. I've got my marking end on the other. Now this is not technically gonna mark on the dry erase board, but I'll mark it with the dry erase marker. So the first one is gonna be to right here. So on yours, you'll be able to use your compass to make that little arc length like that. This is A. Now I need to do the same thing with B. I'm going to bring my compass in, make sure that I'm touching both ends. Looks good. I'm going to stick that right there where I finished that one, and I'm going to add this part. So I'll mark it first, and then this is B. And now I'm going to do the same thing with C. Stretch it to where it just touches. Go, get it here, C. All right, so from this point right here to right here is my A plus B plus C. All right, we'll notate it like this. So right there, that's A plus B plus C. All this is just extra. I could erase it whenever I need to do. There's my A plus B plus C. That's how I'm going to represent that one. The second wants me to represent we'll call this in double I, A plus the quantity of B minus C. All right, so that one's gonna look a little bit different. First, I need to find one is my B minus C. So, I'm gonna have to do two lines. I have to find my B minus C first. So I need to make one long enough to get B and C together. Alright, so I'm gonna find my B. I'm going to find my C. And I'm deducting it. Should match this up to exactly what you need here. So this is my B minus C right here. And now I want to do A plus whatever B minus C was. So I've got my B minus C right here. I'm going to make my line again. Long enough to add A plus B minus C. So A, there we go. It's going to go right here. I'm going to B minus C, this little line segment right here, and mark it. This is A, this is B minus C, and together, from here to here, is my A plus B minus C. All right. Next, it wants us to do A minus, put it over here. A minus the quantity of B minus C. So I've already got my B minus C. So I need to make line long enough. I need to find my A. There's my A minus B minus C, so B minus C I've got right here. I'm going to subtract that from it. So this whole thing is my A from here to here. This is my B minus C, so this little portion right here is A minus the quantity of B minus C. All right. Next, it wants us to find 2A. All right, so number 4. It wants us to find 2A. Well, what does 2A mean? 2A means 2 times A. So make sure I'm line up to do A in there twice. is A, this is A, all together, that's 2A. All right, and last, it wants us to do 3A minus 2B. A minus 2B, so one, two, I barely made it long enough. 3, this is A, so from here to here is 3A. Now I need to do 2B, so there's my B. I'm going to start here, and I'm going to start taking off. There's 1B. There's another B. So I'm left with, from here to here, that is 3A minus 2B. That's what's remaining. That's the leftovers. All right. So that gets us through all the different ones on number 1. Looks a little bit different with adding and subtracting and multiplying lines. We've done a ton with numbers, maybe a little different whenever we're doing geometry. All right. Number 2, take any line AB and divide it by any 2 points into 3 parts X, Y, and Z. They have a drawing there on the left side. Construct a second line, CD, equal to AB. Use a compass to make sure they're equal. On a third line, EF, lay off a line, EH, equal to X plus Y plus Z. X plus Y plus Z. All right, so let's look at that. All right. The first things it tells us to do is to take any line AB. So I'm going to make a line AB. Okay, this is, I'm going to be careful about, I've got a little compass, so I'm going to make it shorter. This is from A to B. That's the line AB. And it wants me to break it into 3 parts with 2 points. So if I break it here and here, this is X, Y, Z. I broke it into 3 parts, X, Y, Z. Then it wants me to make another line. This line we're going to call CD, and it wants it to be equal to AB. So I'm going to use my compass. And I'm going to make my points. So here is CD, right? Yep. C to D. Use my straight edge. Alright, that's the equal using my compass. Then it wants me to make a third line, E to F. So this is E to F. And it wants me to lay off, take away a line E to H that is equal to X plus Y plus Z. So I'm going to lay off X, Y, and Z. So X that's my X. y that's my y and z. All right. Now it said to lay off line E to H off of E to F, which means that this endpoint right here is going to be my H. So now I have a new line that goes from E to H. I laid it off of this longer line. So this part is disregarded now. I have line E to H right here. All right, that should look like what you have on your page on the left side there. All right, so we've done that. Now on part A, it wants us to compare CD to AB. So part A. It wants us to compare line CD to line AB. And what we know about that is that line CD is equal to line AB by construction. All right, we talked about construction on the last lesson. It's equal because I used my compass to make it from line AB. So they're equal to each other by I constructed them equal to each other. It wants us to compare EH. It wants us to compare line E to H with A to B. All right. So E to H is equal to AB because AB is x plus y plus z, E to H is x plus y plus z. So they're equal to each other because they're both equal to that. So both equal to x plus y plus z. The last thing it wants us to do is to compare EH with CD. So it wants to compare EH to CD. All right. CD is equal to AB. We know that because we've already said it right here. It's equal to AB by construction. All right. EH is equal to AB. We talked about it right here. They're equal to each other because they're both equal to x plus y plus z. Therefore, and this is a new symbol, therefore, that's basically anytime we do a proof, because CD is equal to AB and EH is equal to AB, if CD is equal to that and EH is equal to that, then CD also has to be equal to EH. All right. And this right here is principle 4. Lines equal to the same line are equal to each other. So if line CD is equal to line AB and line EH is equal to line AB, then line EH or CD has to be equal to EH. That's principle 4. Lines equal to the same line are equal to each other. All right, so it's very intuitive that makes sense, but now we're using it to prove those things. Let's see, number 4. Number 3 was to illustrate how it illustrates principle 4. Number 4 says line AB. What statement made in answering exercise 2B illustrates principle 5? So principle 5 tells us that the whole is equal to the sum of all of its parts. All right. So line AB was divided into 3 parts, x, y, z. Therefore, AB is equal to x plus y plus z. So principle 5 states that the whole is equal to all of its parts. The whole is AB. Its parts are X, Y, and Z, and the whole is equal to all those three things added together. All right, again, pretty intuitive, but it's going to come in real handy. Number 5, in exercise 2, compare the line represented by X plus Y with AB. All right, line A to B has a length that is greater than the segment whose length is the length of X plus the length of Y. So principle 6 says that the whole is greater than any of its parts. If I compare line XY to the whole is greater than its parts. That's principle 6. The whole is greater than any of its parts. Number 6, select 4 lines, A, B, C, and D, such that A is equal to C, and B is equal to D, and A is greater than B. All right, so 4 lines. The first one, I believe we're done with all this. If not, we'll just do it again. All right, so it wants me to construct 4 lines. It's telling me it wants A, B, C, and D. So I'll make line A. That's line A. It wants me to make line A equal to C. Line B is equal to D, and A is greater than B. So let's go ahead and make line B. There's no stipulations on what B has to be. So this is B. A is greater than B. We see that. A is greater than B. They also want A to be equal to C, and they want B to be equal to D. All right, the only way I can make sure that those are equal is to use my compass. So line C, A needs to equal C, so I'm going to use my compass. And I'll go ahead and make my 2 points for B, off of B for D. Use my straight edge. Okay, this one is C and this one is D. So using my compass, I know that A is equal to C, B is equal to D, A is greater than B. So we're done with that, so we've got our 4 lines. Now we want to show that A plus B is equal to C plus D using our compass and straight edge. So I need to find out what A plus B is. So I'll make 1 line for A plus B, and I'll make another line to show C plus D. Okay, A plus B this is A and B, C plus D, and you can just open it up. There's AB, CD are equal. So when I added A and B, C and D, they are in fact equal. All right. Number 7 says illustrate principle 7 by using numbers. So principle 7 tells us that if equals are added to equals, the sums are equal. All right, so if we want to do that using numbers, let's just say let A equal 3 B equal 1. Alright, we'll let C equal 3 and D equal 1. Alright, so I've got equals added to equals. So I want to see that if I add two equals, does it equal two equals being added to each other? So I'm going to substitute 3 plus 1 equals 3 plus 1. 4 equals 4. That is true. So we have shown principle 7 there. Number 8, show that A minus B and C minus D using the information given in exercise 6. So we've still got A, B, C, and D from exercise 6. So show that A minus B equals C minus D using those. So we'll do the same thing. I've already showed that A plus B is equal to C plus D. Now I want to see that A minus B is equal to C minus D. That would be principle 8 if this turns out to be true. Principle 8 says that if equals are subtracted from equals, then the remainders are equal. So, line A minus line B C, this is A, this is B, minus D. All right, so now I'm going to test it. This is what I'm left with. This is A minus B is equal to C minus D. So when I add them together, it checks out. When I subtract them, it checks out. Number 9 says illustrate principle 8 by using numbers. So same thing. If I I'm going to let A equal 3 and B equal 1 again, C equal 3 and D equal 1. Now I want to show that A minus B is equal to C minus D. So I get 3 minus 1 equals 3 minus 1, 2 equals 2. That checks out. That's pretty good. So we've shown it both geometrically. This is how we show it with geometry. This is how we show it algebraically. We've proven it both ways. Number 10 says if A equals C, then show that 2A equals 2C using your compass and straight edge. So we already have A and C here that are equal to each other. A equals C. Now I want to show that 2A equals 2C. So does 2A equal 2C? That's what we want to know. So we're going to take A. Do both lines again. This line is going to be for 2A. This line is going to be for 2C. And I want to show that we're the same. So and I just made it big enough. Have C. This is A and A, C and C. Don't open up enough. My compass won't open enough for 2A, but I've got 21 centimeters and 21 centimeters. So, yes, 2A does equal 2C. Alright, so number 11. Illustrate principles 9 and 10 using numbers. So doubles of equals are equals, halves of equals are equals. So if I let, this is number 11, oh sorry, yeah, number 11. We'll let A equal 3, just like we have. Just gonna do it off on hand. We'll let A equal 3 and C equal 3. So if I do 2A equal to 2C, that's what I'm left with. Replace my variables, I get 2 times 3 equals 2 times 3. I get 6 equals 6. That's true. So that shows principle 9. Principle 10 wants me to do the same thing, but it wants me to do halves of it. So if I say it's saying that 1/2 A is equal to 1/2 C, 1/2 times 3 is equal to 1/2 times 3. So I get 3 halves equals 3 halves. That is true. Alright, so we've shown principle 9 and principle 10 using numbers. Alright, the last thing is it wants me to draw 3 lines, A, B, and C. So it's selected that A is greater than B, B is greater than C. Alright, so let's go and erase all this. Alright, so it wants me to draw lines A, B, and C so that A is greater than B. So I've got this is A, and I need it to be greater than B, which is greater than C. Alright, so A is greater than B, which is greater than C. Without measuring the lines, tell what relation A should have to C. Alright, so we want to know without measuring what relationship should have A and have to C. We know that the 3 things we talked about is it's either going to equal C, or be greater than C, or be less than C. That's what the relationships can possibly be. It's either going to be equal to, greater than, or less than. We want to know which one. Well, A is greater than B, so we're going to, and just looking at it, we're going to assume A is greater than C. Principle 11 tells us that if the first of 3 quantities is greater than the second, the first one is greater than the second, A is greater than B. And the second is greater than the third. The second one is greater than the third, B is greater than C. So the first one, A, is greater than the second one, which is greater than the third one. If that's true, then the first one has to be greater than the third one. All right, that's what principle 11 tells us. Now we're going to verify it. So when I measure line A, and I compare that to line C, it is in fact greater. So A is greater than C. That's what we anticipated was going to happen. That's what principle 11 told us was going to happen. Now we've seen that that's what happened. All right. So there's a lot to learn here. You're going to have to really get these down. You need to be able to call these from memory because some of the questions on the quizzes and homeworks are going to ask you by which principle is this true, and you're going to have to know which one it is. All right. So really, really prepare. Really, really study. Make flashcards. Use Quizlet, and get these things down. All right. You have. Looks like about 4 problems on exercises 1.4 that you can work on, get some practice. That'll kind of get you prepared for quizzes and hopefully prepared for the test. All right, so that's geometry section 1.4.